Hey everyone, in today's video I'm going to show you how to replace a multi-section electrolytic capacitor. If you're working on a piece of vacuum tube gear from the 1960s, chances are very good it's got a multi-section electrolytic capacitor inside of it for the power supply. This is basically a capacitor that contains more than one capacitor inside of one package. So like this one right here, there's actually 4 different capacitors inside of this one can. I'm going to show you exactly how that works, how you can identify these, and how you can get a replacement. Today's video is sponsored by Antique Electronics Supply, or tubesandmore.com. They generously sent me these 3 multi-section capacitors that are going to be direct replacements for the 3 found in this Mac 1500 stereo receiver. These capacitors from CE Manufacturing are the best option for getting a direct replacement for this style of capacitor. They're made in the USA, and they're made using the original equipment that was made to use stuff like that back in the 1960s. I will link a video in the description of their manufacturing process that you can check out if you're curious. I will also show you the hard, sloppy way to replace these, which is what I've done with this bogan. I did that using individual electrolytic capacitors like this and a terminal strip. After you see what I did to make this style of thing work, you're probably going to want to buy one of these CE manufacturing capacitors from tubesandmore.com. So without further ado, let's get started. First thing we're going to do is replace the 3 multi-section capacitors in this Mac 1500. You can see we've got the 3 of them right here. I went on antiqueelectronicsupply.com and found suitable replacements for all 3 of these. Now they're not exactly the same, and I'll show you the process I used to figure out which one of these will work in place of these. Because sometimes you gotta get a little bit creative, but that's okay. But before we rip these out, we're probably going to want to take a look at the schematic and understand exactly what we're doing here. So let's go ahead and do that. So I've got the power supply section of the schematic for the 1500 printed right here, and then this is the section of the parts list that has the caps we're going to be replacing. Ones we're concerned with are this electrolytic right here, this 60-40, this 40-40-40, and then this 50-50-50-50. And we know that these are the ones because they've got, multiple values listed, hence it being a multi-section capacitor. So what is a multi-section capacitor? Let's take a look at this one right here. You can see we've got 4 different capacitors in here, and they're all 50 microfarads at 350 volts. And if we look at the bottom of this, we've got 4 pins right here, and then we've got these tabs for the case. So basically how you read this is, you see these little symbols right here? We've got like a D, a square, a triangle, and some dots right here. Underneath here, if I zoom in for you, you can see those symbols printed on the bottom of this thing. So now you might be wondering, where is the negative on this thing? Well, it's the case. So on a traditional radial leaded electrolytic capacitor, you've got your positive end and your negative end. This thing has 4 positive ends, these 4 in the middle right here, then the negative end is the case. So let's come back to the schematic here. We see C124 is going to be a 50-50-50-50 at 200 volts on all 4 capacitors. This is an exact replacement. We've got 50-50-50-50, but this one's 350 volts, so it's an even better replacement. And we see on the schematic right here, we've got C124A, B, C, and D. So that's kind of showing the 4 sections of the capacitor. And what happens here is you've got different voltages you want throughout this unit. So you take this leg of this transformer and you're putting it through this resistor first to drop down the voltage a little bit. Then this capacitor right here, this section has a certain voltage. Then you drop it through this resistor, the voltage gets a little lower for section B. This resistor for section C drops it to, looks like 120 right there. And then this last resistor right here for section D drops it to 114. So that's kind of what's going on here. Like, you come in hot with your transformer on one of these, put a resistor from here to the next one, resistor from here to the next one, and then, like that. We'll see that in the unit. That's basically the gist of what's happening here. Now let's take a look at C120. We see that it's a 40-40-40 with different voltages for each of the capacitors, but for our purposes, we've found this one, a 40-40-40, and all of them are at 525 volts. That's going to be just fine for us. Anyways, we see the same thing up here. C120, A, B, and C. So right here we come through a resistor. We've got this voltage right here, looks like 348 volts. Go through a resistor, then we get, looks like 200 something. Then we go through another resistor, and then we've got like 60 up here. So that's what's going to happen with this capacitor. Now these two are great because they're basically drop-in replacements for C124 and C120. But for C119 I had to get a little bit creative. So what we've got here for C119 is a 40, 20, 20, 20, all at 525 volts. And you might be thinking, well, that's kind of interesting. Why would you buy a capacitor with 4 capacitors inside of it just for one that needs 2? Well, Ohm's law states that if you put capacitors in parallel, you add the values and that creates one capacitor. Conversely, if you put 2 capacitors in series, the capacitance is reduced. So it's basically the opposite of resistors, if you know Ohm's law and resistors. So what we can do here is, in order to achieve the 60 right here, we've got the 40 and the 20 at pins D and square. So I go down here, I see pins D and square right here. I'm just going to connect these. I'm going to solder these directly to one another with a little jumper wire. So that's going to give me my 60. And then, what do I have left? I've got two 20s. 20 plus 20 is 40. So then I'll just solder these two together, and that's going to give me a 40 for this capacitor. I'm going to be using all the pins here. So briefly, I just want to show you how you find these multi-section capacitors on Antique Electronics Supply or tubesandmore.com. And don't forget, if you use code AHFIX10, AHFIX10, you get 10% off your order. So let's go to capacitors right here. We're going to click under type, multi-section can type. And now what we're going to do is we're going to look for, what we need. So we see that we have many to choose from. Let's pick a capacitance value that we know we're going to need. So for example, let's check 50 because we know we needed that 50, 50, 50, 50. And we see this one right here. We had a 250 volt originally. Now we see that we have this 350 volt with 4 50s inside of it. That's going to be perfect. If this were lower than 250, we'd have a problem. But since it's higher, that's going to be okay. And now we look down here, we have more, like here's one that has 50 at 300, but it's also got a 10 and 230s. So this one's kind of interesting. You see some more interesting ones down here too, like you got a 150, 80, 80, 50. And I'm sure these all coincide with common amplifiers out there. We're lucky we were able to find what we needed for the Mac 1500. And I suppose you're going to be lucky if you find what you need too. Otherwise, you'll have to get creative like I did. So, like we know, we had to have that 60-40. So what I did was I searched by 40, and I found this one right here, our 40-20-20-20. Before that, I was searching by 60. So let's clear this, and let's search by 60 and see if there's anything that works for us. You see we've got a 60-40-10-25. That's not quite going to work. Then we've got a 60-40-40-40. But it's only at 400 volts. That's not going to get up to the 500 that we needed. And then we have this 450, 60, 30, 30. Again, not quite going to line up for what we need. So the last thing to note with these is you're going to want to make sure you don't get one that's too tall. So always be sure you're paying attention to the height, which is listed right here. Like this one is 3 inches high. This one is 2 inches high. So always make sure you're not going to get one that's too tall. Shorter's fine. Higher voltage is fine, but you don't want to go lower voltage and you don't want to go too tall. So now that you know what these are, how I found replacements, and how we're going to wire them in basically, let's get underneath the Mac 1500 and start replacing them. Here we are. Right here is where our capacitors are. See, we've got some of those resistors between the leads, like this one right here. We've got one over here, and then we've got just a bunch of wires going to here. It looks like we've got slightly different mounting styles for all 3 of these, so it's going to be a real fun adventure replacing all of them. Let's start with the 60-40 right here, because I think that's going to be the most straightforward. But wait, before you do anything, you're going to want to check these for DC voltage and make sure there's none there, because you saw some of the voltage values on these things. It's high. We want to make sure we're not about to electrocute ourselves, so we'll just put one of these to ground, and we'll check this one right here. We see there's nothing. Check this one, there's nothing. We'll check the other pins on the other capacitors. We see that there is nothing on any of them, which is excellent. So we are safe to work on this. Okay, so we've got the nuts out and some screws came out from down below. Here they are. Next thing we want to do is take a picture of this and note that the red wire right here is going to D on this capacitor, and this orange wire is going to triangle. So now that we have that picture, we can start cutting wires. We're going to want to leave as much of this wire as possible because, as you can see, there's really not that much to work with here. So now that this is out, you can see we've got this little mounting plate right here. What we're going to need to do is we're going to need to twist these tabs so that they can slide through, and we're going to need to desolder this one. You can buy these new on Antique Electronics Supply, but I forgot to ask for new ones, so we're going to do our best and reuse what we have. We will also want to desolder this resistor because it might still be good, and if it is, we can reuse it. I'll go ahead and do that now. Okay, so there's our mounting plate. We can reuse this. Here is our old and our new. Well, I guess I should do it this way, huh? The old one is a 60-40, both at 500, and the new one is a 40-20-20-20, all at 525. And if you recall, if we put capacitors in parallel with one another, we can add the capacitance of each one and get a new capacitor. So when we put this together, we're going to want the 40 and the 20 together, and we're going to want the 20 and the 20 together. So for the 40 and 20, we see we have D and square. So if we go down here, we see that this one is D and this one is square. So then the 20 and 20 to make our 40, it's triangle and dots, or nothing. So that's these two right here. So what I've got here is I've got a new resistor, and what I'm going to do is I'm going to slide it through like this, and I'm going to solder right there and right there, kind of. So you see what we've done here. We've kind of created a parallel capacitor circuit right here, and then this resistor is going to go, kind of like the old one did. And another note, the schematic for this amplifier says that this is supposed to be a 900 ohm resistor. This is a 180 ohm resistor, or something thereabouts, and it was across here, and it was across there, and you probably noticed it was very ugly. I think somebody replaced this resistor once and replaced it with an incorrect value. So this one's a 1K, so a little bit above 900, but I put it in, checked the voltages, and they're close to what we're supposed to have. So I'm going to send it with this 1K. I think at this point it's time to mount this thing back in here since we know how we're going to do this. Take this out for now. We will reuse our little thingy here. And we see that we want to sit about like this. So let's see, how can we mount this here? I think that's going to look pretty good right there. Now, you may have noticed this old one was taller than the new one, and what we had going was we had these little standoffs in here so that it would kind of hold the thing further inside the unit so it wouldn't stick out so tall. We don't need that anymore since our new capacitor is quite a bit shorter. So we're just going to screw directly to the chassis like this with our screw and nut and bolt and nut. I think what we're going to do first is we're going to secure this thing to the capacitor, because that's really how this thing sits in here. It's probably going to sit kind of like this. We've got our 60 right here, and then our 40 right here, which lines up with the orange and red wires, and then we can probably use this guy for the ground wires right here. So that means I will take this tab right here, and I will just twist it. And that right there, it's already pretty dang solid just by doing that. So now let's do that over here also. Now I've got a nice solid mount here. Then I think we're going to want to solder this right here. And then once it's in, we'll solder our wires to that one. We're going to want the iron nice and hot for this. So we'll just go in like that. So we're just going to hold it there a minute. And then I'm going to add plenty of solder and make sure we are actually soldering to the plate here. I want both things to be very hot. I think I've done that. Oh yeah, that's great. See, look at that. We've got excellent penetration. That's a welding term, but that looks nice. Both of these got very hot, and that's a solid connection. So now I'm going to feed this under here, and we can work it up through here. Luckily, looks like I still have enough in my socket to get a nice tight grip on there. So this one is officially in, per se. Now it's time to get our resistor back Now I think we can take the red wire and let's run that through, oh, I don't know, this one. And take the little flathead screwdriver and wrap it around the terminal just a little bit. That's nice-ish. Take the orange wire, do the same thing. And then our black wires, they're going to go in that tab that we left untouched. Okay, so I've kind of bent these up a little bit. I kind of brought in the resistor leads a little bit. Got these bent, and then I'll bend this resistor up when I'm done, once everything is soldered in. Here I go. There it is. As you can see, everything is soldered in. I made sure those little holes in the hooks were closed up by the solder, so it looks real nice. There you go. One soldered in multi-section capacitor. Now we just need to do it 2 more times for the others. I think the most challenging thing is going to be getting them out, actually, because they're riveted in, not fastened like the other one. I see this little thing is attached to the chassis also, so we'll have to get that out carefully and not break any of the stuff on it. So this middle one here, I did need to drill out the rivets, and we're going to need to extract the mount that is on here. But this other one here, I did not need to drill out the rivets. We'll figure this one out as we go through, but for now, I'm going to start working on this one here. I've taken pictures, so I can begin cutting this out. So you can see we have a non-conductive plate for this one. So we'll need to carefully remove this and see if we can reuse it. Voila. Anyways, this is the 40-40-40 right here. And now we have our new 40-40-40. And this thing fits right over. Perfect. And now we just gotta install it. I think I'm going to use some 440 screws and nuts for this to get this back in to replace the rivets. And that should be pretty good. Okay, so I got the new one in. I used 440 hardware like I talked about using. It was kind of difficult, especially with this guy, because this is actually secured by one of the mounting screws. It used to be riveted in. And it was a little scary drilling this one out because I had to get the drill bit like in there. It was a little scary, but here it is. I've got the wires stripped, and now it's time to solder the wires where they go. Yeah, looks like nothing even happened. That looks exactly the same as it used to. Now let's figure out how we're going to get our last one out. I'm not exactly sure just yet. We have a fairly large number of wires going here, so should be fun. Okay, so I've snipped all the wires. I think I'm going to start trying to just bend these tabs until they break, like so. I just got the one. Aha. Now we've got some movement. Okay, so it looks like we're about to be set free. All I had to do was break the 4 mounting tabs for the plate. So I guess what they did with this one is they put this plate in here, and then they took this capacitor and they went from underneath and then bent these tabs so that it was locked into the chassis that way. I'm also going to try to reuse this resistor after I test it. I'm going to remove it from the capacitor with my Heiko. This is a 680 ohm resistor, and it tests perfectly at 680 ohms, so it's getting reused. We'll just stick that right in here. And I took note of, on the old one, which, D, square, triangle, and nothing. like where that was in here, and I'm going to do the same thing on this one because this is another capacitor where all four are the exact same. So for consistency's sake, this used to be on D and the nothing one on here, so we're going to put this on the D and nothing one. I think I'll start by adding the nuts and bolts here and securing those. And then what I just did out of your sight is I put this through and I twisted the tabs while I was applying pressure on the other side. So now this is quite solidly in there. I'm moving that around with my finger and it's not moving. So now it looks like all we need to do is strip the wires and solder them, and that's a job. And there it is. All three of them are replaced now. Now it's time to see if everything still works. So let's flip this over and turn it on. Okay, everything's replaced on here. We've got the brand new caps. Let's turn it on and see if we get sound. And there it is. Sounds excellent. So now that we've seen how well those capacitors integrated into the Mac 1500, I want to show you this Bogen CHB50 because I took a pretty different approach with this one on how to replace its multi-section can. So first of all, here it is. We see we've got the multi-section capacitor right here. It is a 2020-1010 microfarad. 20s are at 450 volts and the 10s are at 350 volt. So let's go underneath here and let's see what I did. Now, prepare yourselves because it's ugly. And that's okay sometimes, but you know, depending on what you're doing, maybe this is completely unacceptable to you, but regardless, this is what happened. Essentially what I've done here is I've taken the four capacitors, I combined two into one, and then I have the remaining third and fourth in these guys right here. So you can see they're all mounted to this terminal strip right here, and I've got four terminals on there, and there's 3 wires for them to go to. If we look at the schematic of this, I'll put it on the screen, you'll see that the two 20s are actually in parallel with one another, making a 40. So what I did was I took a 47 450 volt and put it in place right here. And then the remaining 10s, in the schematic they actually say 20, so I used a 22 450 and another 22 450 back here. And the way they're all going to ground and they have the resistors going through them is like so. So let's take a look at this terminal strip here. What you can do is you can call this one ground and solder it to your chassis because, you know, this is how you got to mount it. That's how this one's mounted. It's soldered to the chassis. So for our first capacitor, let's say it's this one, we're going to put our first thing through right here. On this one, our positive is through the non-grounded, and then this grounded one is right here. Let's say we want to go to our next capacitor here. We want to go from this positive to another positive on here, but we need a resistor. So what we can do is we can take this resistor, we can mount it right in here, bend our leads. Now you see how this resistor is now going from this terminal to this terminal. So now this voltage right here is being stepped down to go to here. Sorry. And now we can take this capacitor, we can come in from the back end and say, all right, I want to put the positive end through here, and then I'm going to ground the other one here. So I mean, this is kind of confusing to show on camera. Probably better if I drew a schematic, but the point I'm trying to make here is that this is a less ideal way. You know, this looks horrible in here, and the reason I did it is because I had the space, and this is not a very high quality piece of gear. These aren't built or designed to the same standard as a piece of Macintosh gear. This is kind of a bare minimum tube amp, basically. So something like this on this thing is fine in my opinion, but you saw on that Mac 1500, think back to how tight everything was in there. There is no room in the Mac 1500 for you to do something like this. So that's the quote, wrong way to do it, but it is a way you can do it. Now, the last thing you'll want to do is go underneath and make sure that you've got all the voltages you're supposed to have on your schematic, like right here. I'm not going to do that on camera. I'm just going to wrap this video up here. So that's it. Thank you so much for watching. I hope you learned something watching this. Thanks again to Antique Electronic Supply for sending these capacitors, allowing this video to be possible. And if you have any questions, leave them in the comments. I'll see you in the next one.